Hello, in this lesson we'll talk about evaluation of time schedule. How we can evaluate time schedule and judge the schedule if it is good or not. We have to know if the schedule is good or not. Therefore, we should evaluate the schedule and to design a checklist to judge the quality of the schedule. DCMA 14-point schedule assessment is one of the methods to evaluate the schedule. USA Defense Contract Management Agency, DCMA, is responsible for Federal Acquisition Program. DCMA has developed and released a 14-point assessment check protocol to be used for CBM schedule reviews made by their department. So DCMA designed a protocol to evaluate schedule according to 14 points. We can consider this framework for schedule quality control, and also have to know that DCMA 14-point assessment is not a standard, only a guideline. There are 14 points as a guideline for us to evaluate the schedule. The first point is logic. DCMA says that the number of tasks without predecessor and or successors should not exceed 5% of the total task. That we call it open-end activity. That activity has no predecessor or no successor. The standard of DCMA 14 points in this point that open ends not exceed 5% of the total task. Second point of logic, to avoid dangling activities. What is the dangling activities? Let's see this example to explain what is exactly dangling activity. In this schedule we have activity A. In this schedule we have activity A and B. Activity A has predecessor, finish to start, and has successor, start to start. Both predecessor and successor are linked from the beginning of the activity. There is no relation link the end of the activity. So the activity is considered as dangling activity. So activity A and activity B, we call it dangling activity. They are linked from one side, from start or finish. To avoid this problem, we have to link activity A finish to other activity. Second point of evaluation according to DCMA, what we call it leads. Leads means negative lag. So DCMA advised to avoid negative lag in our schedule. The reason of that, according to DCMA, they said leads may distort the critical path. So the standard here to avoid leads in relationships. This is an example to explain the impact of negative lag on the schedule. We have a project consists of 3 activities. We link these activities with finish to start with negative lag. And we make another method to link activity, same activities with same duration. We link it there by finish to finish, positive lag. And we have another method to break down the activities. So we have the same project, we repeat it 3 times. First time we finish to start with negative lag, the second finish to finish positive lag, and the third we break down the activity, and the schedule we get finish completion date, the same completion date in the 3 methods. When we make updates for this project, for the 3 methods, for first method with negative lag, we get completion date here even we have a delay, a big delay, but the compilation complete on time. In the second method, finish to finish with positive lag, we have a delay in this project, and we can see the critical path here and compilation date. We have a delay in the compilation date, and when we break down, we get other critical path and other compilation date. So negative lag give us a misleading and wrong compilation date. So DCMA advised to avoid negative lag, what we call it, leads. Point number 3, according to DCMA, what we call it lag, consider here it is a positive lag. So percentage of predecessor relationships that have a positive lag values should not exceed 5% of the total number of relationships. Thank you.